In this video, we're going to illustrate to you a loan amortization assuming equal total payments. We're going to assume only annual payments just so we can keep it simple, because the purpose here is to show you how to break the payment into the components of principal and interest. You already know how to make adjustments for monthly loans from other exercises that we have done during the semester. In this problem, we're going to put the amount borrowed, the term, and the interest rates. We're going to call those loan parameters, and we're going to put them in a box actually separate from the amortization table. So as you're looking at the screen, this area right here is your amortization schedule. And this information up here is simply the parameters of the loan. We're going to do this now so that you can change those parameters, and automatically the amortization table will make the adjustments for you. You could build the amortization table by putting the parameters directly into the functions, but then you couldn't make any changes. Okay, so let's begin. We're going to assume $80,000 is borrowed. We're going to borrow that for 5 years. Now here's an important point. Be sure you do not type the word years or the abbreviation for years in the same cell with the 5. If you do that, Excel will misinterpret that as a word and it can't do the calculations. For the interest rate, we must enter it as a percent or as a decimal. This is different than your calculators, where you can enter it as just a number and it'll make the adjustment, but Excel doesn't. So this has got to be either entered as like 7% or 0.07. Okay, so let's take these loan parameters right here and actually begin to build a amortization schedule that actually takes each one of the 5 payments from the 5 years and breaks it down into its payment, its principal, its interest, and the outstanding balance at the beginning and the end of the year. Okay? All right. When we start this loan in the first year, right here, we know the beginning balance. In other words, the beginning balance is how much you hadn't paid back. So it's simply, I'm going to type equals and go click on the $80,000 and hit enter. Okay? Now, by using a link, I could put any number here and it would automatically go to that beginning balance. Okay, so if you borrowed $80,000 for 5 years at 7%, what would your annual payments be? In other words, what would be the total amount of the check you write once a year? So that's this column called payment. Now you already know from other exercises that that payment is really a present value problem. It's the present value of an ordinary annuity. The payment is going to be constant each one of these 5 years. So in this area right here, what we're going to have is the same number, the same exact payment. You know that you can do that with a hand calculator, a financial calculator. You know you can do that with a mathematical formula. You know you can do that with a table where you look up the interest rate and the number of years. So this is really a fourth option. We're going to show you how to do this in Excel. Now Excel has functions that are pre-programmed into the software. For payment, it is a function called PMT. To get that function, you can access it a couple of ways. One is you could simply go equals PMT, open parentheses, and then it'll show you right here the different parameters that it is asking for to calculate that payment. However, I'd rather show you as beginning students a different way. Put the cursor where you want the payment and simply insert a function. Now this little f of x right here in Excel is an insert function key, or an insert function button. If you'll click on it, you'll get a new little dialog box over here. And in this dialog box, you could just type in this search bar right here, payment, and it'll go find it for you. But I don't want you to do that. I want you to go through the steps, because you'll learn where things are located. Right here at the drop-down menu, there's a very large section of categories of functions. You want to choose financial right here. Now, once you choose financial, everything in this bottom box will be a financially related function. So you simply scroll down till you find payment. Okay, there it is right there. Now it gives you a little description of what it does. Now when you click OK, you're going to get a new box, and it's going to ask you for the parameters of this loan. Okay, you don't want to type in the actual numbers because then you would have no flexibility to make changes. So we want to use links. So where it says rate right here, just go right over and click on the 7. Now, that 7 is going to be a constant percent in all these payments in this grayed area. So what you need to do is to freeze that 7 so that you can automatically fill all those cells and not have to type this formula every time. Now to freeze that cell, you need to put a little dollar sign in front of the E and a little dollar sign in front of the 7. In other words, the row or the column and the row. However, it's just much easier that once you click on the 7% to go up to the top of the keyboard and enter F4. The F4 key will automatically put those little dollar signs. Those are called absolute references in Excel. All in the world we've done here is freeze that 7% so that when we take this formula and grab it and fill downward, it'll always refer to that 7%. It won't make an adjustment. All right, the number of periods in the loan is 5 years, and I'll F4 it. And the present value is the amount borrowed. Okay, so I'll click on the 80,000 and I'll F4 it because I want those to be the same for every year of the loan. Okay? And right here it'll preview what the payment is. Now you'll notice, just like on the calculators, if you're calculating basically a present value problem, so your payments are going to come out as negative. If you don't want to happen, if you want it to not have a group of negative numbers, the easiest way is to go back to your amount borrowed and simply asterisk -1. In other words, multiply it by -1, and it'll simply turn that into a negative number, and then your payments will come out as a positive number. When I click OK, it'll put that payment right there in year number 1. That's the first payment. Because I made each one of those parameters an absolute reference, in other words, I typed that F4, now I can drag that formula. Get right here on the bottom right where your cursor changes to what looks like a crosshair. Hold down the mouse button and pull down and see it puts that payment in every year. And each one of those payments is exactly the same formula. It refers back to the same 3 parameters of the loan because you froze those and made absolute references out of them. Okay, now each year when you make that payment of $19,511, part of that payment is paying the lender back his money called principal, and part of it is interest, which is a rent on his money. So the principal and the interest must add to the payment. So you will know that these two columns will change over time. They'll be different. The principal and the interest will. The principal actually goes up each year and the interest actually comes down. Okay, to calculate principal and interest, let's do the principal portion first. So to calculate that principal, what we're going to do is we're going to use an Excel function referred to as principal per payment, and it is abbreviated PPMT. All right. Now, put the cursor in the first year, insert a function, go to financial, and come down and find PPMT. When you find it, it'll give you a dialog box. Now, we've got to be careful here. We also are going to autofill that function down. In other words, we're going to copy and paste it like we did with the payment. But we're going to want the year to change every time, because if we didn't, we'd get the same principal each payment, and that's not true. Okay, so here we go. Rate. It's 7%, and I'll F4 it because every year I want that rate to be 7%. This PER means which period. Well, in the first cell, I'm talking about period 1. However, I am not going to make an absolute reference out of that because when I pull this formula downward, I want that years to go from 1 to 2 to 3 to 4 to 5. So I'll leave it without the absolutes, in other words, without the little dollar signs, which means it is a relative reference. The number of periods in the loan, that's 5. I'll F4 that. The amount of borrowed is the 80,000. I'll F4 it and multiply it by -1. So you're right here, you see the preview. The principal in that first period is going to be $13,911. Okay? Now, I can grab that formula in the bottom right, drag it down, and that shows me the amount of principal in each one of the payments. So In payment number one, 13,911 was actually paying the lender back that much of his money. In year two, I pay the lender back 14,855, and so forth. However, every year the check amount is that payment amount, but this is the actual paying back of the lender's money. You can always check yourself to get right below that last year and sum that column, and it's certainly got to equal to the original amount borrowed. All right, so let's go to interest. How much of each payment is interest? Well, you could simply subtract. That would be a real easy way to get that. But the purpose here is to show you the Excel functions. In Excel, the function is called interest per payment. So it's abbreviated IPMT. So we'll go to payment number one, insert a function, go to financial, and come down to interest per payment right here. And again, there's your dialog box. Looks just like the principal per payment. So here we go. Rate, 7%, F4. The period, well, it's the first one. No F4. Number of payments is 5, F4. Present value is the 80,000, F4 asterisk minus 1. And you'll see it previews $5,600 was the interest in that first payment. And again, I can click and drag. And now if you sum this column, it's going to tell you how much total interest you'd pay over the life of the loan. Now you know, common sense, these two numbers here must add to the sum of the total payments because these are the principal and interest. In each payment, the principal and interest must add to the overall payment. So just come right here and hit sum, and you'll see that that total is simply a sum of the total of the principal column and the total of the interest. Okay, let's go to your outstanding balance at the end of each year. The loan balance is the amount of money that you have borrowed from the lender minus any principal payments. So in the first year, at the end of the first year, your loan balance is equal to your beginning loan balance minus principal payments. Now don't make the mistake and subtract the total payment. You can't subtract the interest portion because that's rent that you're paying. Well, if 66,000 is the loan balance at the end of the first year, it's also the loan balance at the beginning of the second year. So the easiest way to do this is just go equals and go click on that previous year's balance. Now, the loan balance at the end of the second year is simply equal to the beginning loan balance, again, minus any principal. Okay? Now, since you've put formulas in these two cells and you don't have anything absolute, you can drag them. Now, they're going to look a little funny until you get them both drug all the way down. So let's drag that formula down, and then let's come over here and drag this one down. Now, you know, if we've done this correctly, when we turn the mouse loose, that last entry's got to be 0. In other words, the loan's been completely paid off. Okay, so this will show you a loan amortization that breaks each payment of a loan into its payment, and then of that payment, how much of it's principal and how much of it's interest. It's very important that you be able to build one of these on your own. Because when our next quiz in class, you're going to sit at a computer. You're going to be given a set of parameters. In other words, these three things right here, and it will be your job to build an amortization schedule like the one illustrated here.